Hey guys, Jan King here. So we got to keep going on with the diseases. You guys need to know this for the contest, so I'm just gonna keep plowing through. Let's get on to let's get on with it. Chapter 12. So we're on degenerative disorders. This would include things like Alzheimer's, Parkinson's, ALS, Huntington's. Some of the biggest issues that medicine is facing right now. So it's really great that we're studying these. I hope you guys like the chapters as much as I did. This was actually my favorite chapter in the book. So let's get on with it. Alzheimer's disease. So Alzheimer's disease is really, really bad. Essentially takes away a lot of things that make us human. Our memory, our judgment, our calculations, our language. So obviously, it's really, really important that we continue to investigate Alzheimer's to figure out better treatments for it. So exactly what's happening in a patient with Alzheimer's? Well, when you look at the neurology, you see that you get abnormal accumulations of proteins called beta amyloid and tau. Beta amyloid, the abnormal accumulations of it are going to cause neuritic plaques, and abnormal accumulations of the tau protein are going to cause neurofibrillary tangles. In Alzheimer's, these plaques and these tangles are going to be developing in brain regions really important for memory and intellectual functions, and this is the reason why those functions are impaired. You also have to consider the fact the way neurotransmitters are affecting this whole situation. A decrease of acetylcholine and an increase in glutamate have both been implicated with Alzheimer's. Excessive amounts of glutamate causes cell death, and decreased amounts of acetylcholine actually cause a lot of cognitive problems. So the drugs that are approved by the FDA either target acetylcholine or glutamate. Four out of the 5 drugs that we have for treating Alzheimer's right now prevents the breakdown of acetylcholine, and the 5th one prevents glutamate from becoming accumulating in excessive amounts. So right now, to diagnose Alzheimer's, we do have relatively accurate ways to diagnose it. Clinical diagnosis of Alzheimer's has about an 80% accuracy, and as the course of the disease progresses, you can actually increase the accuracy of your diagnosis up to above 90%. We actually use a lot of different ways to diagnose. Medical history, physical tests, neurological tests, psychological tests, lab tests, brain imaging studies. Right now, to actually confirm Alzheimer's, though, you have to actually open the brain and take a look, an autopsy. So right now, research is going on to try to figure out the whole Alzheimer's situation. Some of the research I've seen actually is looking at the genetic side of it. So the gene encoding beta amyloid is the APP gene, the amyloid precursor protein gene on chromosome 21. And a lot of the genes that cause Alzheimer's is dominant. A particular gene that I want you guys to know for Alzheimer's is apolipoprotein E, the APO gene. And a particular variant called ApoE4 is clearly associated with increased risk for Alzheimer's. And a lot of the research that we're doing for Alzheimer's is looking at these various genes to try to figure out what's going on. So that's Alzheimer's. Now let's move on to a talk of ALS. ALS, an incurable condition. It causes the deterioration of your motor neurons, the death of your motor neurons, and as a result, you can't control your muscles and you become paralyzed. And this is actually really, really dangerous because a lot of your body functions depend on muscles. Your breathing depends on your muscles as well. So just shows you how serious of a condition this is. So usually in ALS patients, the first signs of paralysis usually seen in the hands and the feet, or in the muscles for speech and swallowing. But eventually, as the disease progresses, almost all the muscles under your voluntary control are going to become affected, and eventually your whole body is pretty much paralyzed, and death is usually due to some kind of respiratory failure or pneumonia. Again, breathing also depends on muscles, so when you don't have control of your breathing muscles, that's going to affect your respiratory functions. What's scary about ALS is we don't really know a lot about the disease, right? We have no specific test to identify ALS, and in more than 90% of the cases, we don't even know why it occurred in the first place, right? It's sporadic. In about 90% of the cases, it arises in individuals with no known family history of the disease, or for those individuals, we have a lot of theories for why it happened. We have an excess of the neurotransmitter glutamate, dangerous forms of oxygen causing oxidative distress. But again, we have no real knowledge of why it's happening. We do know in about the other 5 to 10% of the cases, though, ALS is familial. It's due to some kind of like gene issue. So now that we're talking about genes, we can talk about the issue of oxidative distress in ALS in more detail. So yeah, so I know we breathe in oxygen all the time, but oxygen in some forms is actually dangerous for your brain and can cause the death of cells. Normally we have a protein that actually protects against such oxidative distress, superoxide dismutase. But in some genetic forms of ALS, in some genetic defects that cause ALS, you see that the gene encoding superoxide dismutase has gone haywire, and thus you don't have a defense against oxidative distress, and it causes the death of motor neurons. So again, there could be a genetic side to ALS. So right now, drugs that we use, we don't have we don't have a lot of drugs that we can use to treat ALS. We do have there are some anti-glutamate drugs that we can use to treat ALS, but we have no real cure for it. Again, ALS is a really dangerous disease. We don't really know much about it. Looking into it would be a good thing, a great endeavor for neuroscience in the future. Huntington's disease. So Huntington's disease is another genetic disorder. It's caused by a mutation in the Huntingtin gene. It's kind of like a molecular stutter in the DNA, and the main symptoms that you see in Huntington's patients, you see the involuntary jerking movement of your limbs, the torso, the facial muscles, which are often accompanied by the mood swings, the depression, the slurred speech, the clumsiness, the irritability. The notable way to describe symptoms would be the Huntington's dance. You can't really control your limbs. And this is due to the death of GABA-producing neurons. And again, GABA is an inhibitory neuron that you really need to for control of your body. But when those neurons die in some, then you get Huntington's disease. Again, this could be due to some kind of mutation in the this is due to some kind of mutation in the gene encoding Huntingtin. And the gene and the protein, the Huntingtin protein, seems to be dealing with some kind of transcription process. So when we see this mutation, scientists are suspecting that the Huntington's disease is caused by the gain of some kind of toxic function among these proteins. Now let's now let's talk about how do we diagnose Huntington's. Well, diagnosis usually consists of a clinical examination and some family history. However, and it's been really, really helpful that now we know that there's some kind of genetic basis to the disease. So Huntington's disease is a good lesson in the ability of gene diagnosis for the future of neuroscience. Now let's talk about Parkinson's disease. So Parkinson's disease is a progressive neurological disorder characterized by slowness of movement, muscular rigidity, walking and balance impairment, and we know that on a cellular level this is caused by the loss of dopamine-producing cells in the substantia nigra. And the substantia nigra is a specific part of the basal ganglia. We still don't exactly know why these kind of why that area is being degenerated in some way, but we know that some researchers believe that you could have like a genetic factor or an environmental factor at play. Research might provide further answers. Right now, we're using levodopa to treat Parkinson's. Levodopa can be used by the brain to synthesize dopamine, and actually, recently scientists have discovered other drugs that can be used in conjunction with levodopa to better figure out the issue. For example, carbidopa. Carbidopa actually it reduces the breakdown of levodopa in the bloodstream. It basically gives levodopa greater fuel efficiency, so to say. that's a metaphor. Essentially, carbidopa allows your levodopa to go for a longer period of time and allows greater levels of dopamine to get to the brain. It also reduces side effects. So right now, and actually an exciting endeavor that people have had for treating Parkinson's is a surgical method. Right now, they're looking into surgical deactivation of certain parts that are overactive in Parkinson's patients, such as the pallidum and the subthalamic nuclei. And actually, it's been shown that this actually works. So that could actually be an exciting endeavor for medicine. So if there's a theme to this chapter, it's that a lot of these diseases are genetic. A lot of them, we have no effective way to cure them yet. There's something going on with a misbalance of neurotransmitters or a protein gone whack or just simply we don't really know. So these diseases are really, really dangerous, and yet they're shrouded in mystery, and looking into them would be a really, really great and worthwhile endeavor for neuroscience. We can truly save a ton of people if we can really figure out a proper cure for a lot of these diseases. Thanks, guys. See you next time.